We're going to talk about 10.5 angle relationships in circles. Let me start out by saying, if you look at the cheat sheet, and this is the last time I'll reference it for now, if you look at all of the angles, like some of them look like this. Is this angle a central angle? I am recording. Thank you for reminding me. It's okay. Is this angle central? It is not, because where is the vertex on the center? It is not. Is it inscribed? No, because where would inscribed be? On the edge. You're learning properties that are not applied to central angles or inscribed angles. So when this says 40 degrees, guess what? This arc is not 40 degrees. I'm going to teach you what it will be. Okay, that's the purpose of this section. All right, so we're going to be learning angle and arc measures, and I'll explain what circumscribed angles are. So here's what you're going to highlight. In blue, what I highlight, you need to write. If a tangent, you're going to highlight it. If a tangent and a chord intersect at a point on the circle, so that's what you've highlighted. If a tangent and a chord intersect at a point on the circle. So this is the situation we have. We have a tangent. What does a tangent line do? Touch the circle once. So here's a tangent line. Okay, and then a chord. A chord goes from edge to edge. If they intersect, then a relationship is formed, and I'm going to show you it. Then the measure of each angle formed is 1/2, which I believe is a blank on your paper, 1/2 the measure of its intercepted arc. So in one color, go ahead and highlight angle 1. Angle 1. In the same color, highlight its intercepted arc. So an intercepted arc is an arc between two rays. So in this case, this arc is between the chord and the tangent. There's a half and double relationship formed. The same thing with angle 2. Go ahead with your second color, highlight angle 2, and highlight its intercepted arc. Okay, so all of the things that you have learned before, they still apply. So let's say the angle here was 50 degrees. Let's say angle 1 was 50. What is the measure of its arc going to be? It's going to be double it, which is 100 degrees. You could find the rest of the circle just knowing this. Because what do you know about the arcs of the circle? They add up to 360. So what is 360 minus 100? 260. Think about this. What is half of 260? 130. Here's why this fits in perfectly. These two angles sit on a straight line together. What relationship will they have if they sit on a straight line? They're supplementary. What is 130 plus 50?
180.
180. So all the things that you have learned before, they still apply here. On your quiz, you might be asked, you may be given 50 and have to find 100, but you also may need to find 130, or you may need to find 260. So you'll need to be comfortable with all of it. So in this one, it says line M is tangent to the circle. Find the indicated measure. So I am going to keep highlighting angle 1 corresponds with 210 degrees. The reason I highlight is to make sure that what I am given helps me find what I need. So the angle corresponds with this arc. So what can I do to find the angle if I know the arc is 210? Divided by 2. Half of 210, 105. So the measure of angle 1 is 105 degrees. Number 2, I want to find Q. Nope, that's not the letter. I want to find RST. So starting at R, go towards S and end at T. So am I going to go down or up around the circle? Up. So does this arc correspond with the 98 degrees?
Yes.
It does. So what can I do to find the measure of the arc? Multiply it times 2. Good. So 98 times 2 is? Correct, 196. All right, 3, I want you to put a note first. It's 2 letters. What do I know about this arc if it is 2 letters? What kind of arc is it? It's minor. So if it's a minor arc, then that means it needs to be less than 180. Okay, so you need to make sure that your answer is less than 180 or you found the opposite arc that you were supposed to. Because this circle only has 2 letters, right? So from X, we either go up towards Y or down towards Y. Which one would be minor?
Down. Oh, no, up.
Up. You want to go the shortest distance, okay? Does this arc correspond with 80? Yeah. It does. So what can I do to find the measure of arc XY? Multiply times 2, which is 160. Good. At this point, you're going to take out a whiteboard and a marker. You're going to practice this. This really wasn't too new. Technically, this is an inscribed angle, because where's the vertex for each of these angles? It's on the edge. So it's really not too new of information. Okay, but you're going to practice 1, 2, and 3. If I tell you that your 3 answers are correct, you can start working on the cheat sheet with what we've already learned. Because some people can take a little bit longer. Correct. So after you erase, you can start taking what we've learned and put it on the cheat sheet while you leave. The first 2 are good. The last one. Where are we writing yellow? It literally looks like you wrote invisible ink here. Whatever you want to write, whatever help you write first. You can write as much as you want on that, as long as it's from this section. You can highlight on it. I'd recommend that too. Correct. Did you number them correctly? Did you number them correctly? That's true, good. Oh, you fixed the numbers. So, we did the opposite. See how our angle is smaller than our arc? Not by 1/2. All right, so angle ABC. What relationship does it have it with the angle right next door? Supplementary, so 180 minus 70 is 110. So if the angle is 110, let's find the arcs. AB, arc AB is the minor arc. It corresponds with 70. So what do I do with 70 to find arc AB?
70
Times 2. So right now we got 110, 140. And then AEB, you can find one of two ways. There is an easier way. If this angle was 110, the arc would be 220. You could have also taken 140 and subtracted from 360. You still get 220. Okay, go ahead and go back to your notes. I believe we're on page 2. Okay, so go ahead and highlight what is in blue. If two chords intersect inside a circle. So go ahead and highlight what is in blue. We have two chords intersecting inside of a circle. Then the measure of each angle is 1/2 the sum. So what does sum mean to me?
Addition.
Yeah, the answer to an addition problem. So it's 1/2, whatever two things are added together. So here's what you're going to highlight with one color. Arc AB and arc DC. So go ahead and highlight in one color. Arc AB and arc DC. These two arcs would help you find angle 1. Okay, so go ahead and highlight all three of these. The measure of angle 1 would be 1/2. I do write it this way, where it looks like this arc plus this arc. If you want to write it some other way, here's what matters. If you notice, each of these arcs, like AB, arc AB is formed by this angle. Arc DC is formed by this angle. So what do I know about these two angles? What are their measures? They're vertical, which means they are congruent. So these two arcs will help me find these two angles. Okay, and the same thing if you take your second color, arc AD and BC would help me find angle 2.
Wait, did we write that in that box?
That's what the box is there for, yes. Measure of angle 2 is 1/2 times its arcs added together. It does matter that they all correspond correctly. So here's what we'll look at in the first example. We've got a y, which is our goal. Find the value of the variable. We've got y, which is across from arc 95. So go ahead and highlight these in the same color. They only correspond with the angles that formed them, which would be these two angles. So 102 does not correspond with y and 95. Are we all okay with that? It's on the side. It would correspond with BC and AD. You don't have to highlight that, because do we know anything about arc A, AD, or BC? Do we know anything about them? No. No, we do not. Arc. These two, we don't know anything about them. We don't know if they're the same. We know nothing about them. But what we can do is use 102 to find the measure of the angle that will help us. So what can I do to find the measure of this angle?
180 minus 102.
Correct. 180 minus 102. The reason is these two are a linear pair, and linear pairs are supplementary. So 180 minus 102 means that this angle is 78. Okay? It didn't matter if you labeled the top portion or labeled the bottom. These are going to be the same. You just only want one of them labeled so we can use this formula. Okay? And it would be that the angle will equal 1/2 times the arcs added together. You don't have to draw the formula. We're just using this. Do we know the measure of the angle?
Which angle?
The angle that corresponds with our two arcs. So which angle corresponded with the y and the 95? The 78.
Yeah.
That's why we found it, because it's between them. The 78 degrees is what forms the y. It's what forms the 95. So the angle equals 1/2 times the two arcs added together. What are the measure of the two arcs? Y and 95. 102 is an angle, not an arc. And remember, they have to be across from each other because they're formed by vertical angles. So I would not distribute. A lot of people want to distribute. I would not. Here's what I need you to know so that you can do this properly. You don't have to write this, and you don't have to write it now or write it ever. But this 1/2 times y plus 95 is the same as y plus 95 over 2 times 1 is 2. If it were written like this, which these are equivalent, again, you would just put all this over 1. 1 times y plus 95. 2 times 1. If it were written like this, what would you do to get rid of this divided by 2, or this 1/2? What would we do? We would what? We would multiply by 2, which is what we are going to do. You don't have to write it like this. I just wanted you to explain why we're going to do what we're going to do. In order to get rid of the 1/2, you have to multiply by the opposite of 1/2. The opposite of 1/2 is 2. But if I do it on the right side, I have to do it on the left side. So times 2. Both sides. This is the most common mistake I've seen today. People forgetting to do it to both sides. So here's what happens when you multiply times 2. On the right, the 1/2 goes away and the times 2 goes away because they cancel each other out. 1/2 times 2 is 2 over 2, which is 1. They cancel each other out, which is the goal. Okay, so on the right side, the 1/2 is gone. On the left side, though, we had to do 2 times 78. 2 times 78 is 156 equals y plus 95. Subtract 95. What does y equal? 61. And you could always check yourself. If y is 61, you can always check by plugging it back in. 78 should equal 1/2 times 61 plus 95. What is 61 plus 95?
156.
Yeah, oops, forgot the 1. And what's 1/2 of 156? 78. That's correct. So this is just me checking in red. Do we have questions? Okay. So we do this when chords intersect inside of a circle. Okay? I believe we just go to the next page at this point. Here we go. Or no, you don't. Is this at the bottom? Sorry. You won't see this picture at the bottom. I'm just explaining. A circumscribed angle is an angle whose sides are tangent to the circle. So what it is, there's an outside angle. What is the outside angle in this picture? Angle B. And it's formed by 2 lines. What kind of lines are each of these? Tangent, because they touch the circle once. So there is a special relationship. There's 2 ways to solve for this kind of angle, and I'll explain both of them. Okay, but before we do, looking at this, all 3 of these are slightly different, but they all have the same property, and I'm going to explain why. Go ahead and highlight what's in blue, because it is the situation we have. You either have a tangent and a secant, or you have 2 tangents, or you have 2 secants intersecting outside of the circle. So you are forming an outer angle, if you will. In this first example, what is the top line? What kind of line is it? A secant, and the bottom is tangent. So that's that first example. What kind of line are both of these? Tangent. And then what kind of line are both of these? Secants. Okay, so that's all of the situations that you'll be in. But the solution is the same. The property is the same. What you're going to do is you're going to take the, bless you, you're going to take the outside angle. So you're writing this down. You'll take the outside angle, and it will be 1/2 times the bigger arc minus the smaller arc. So a bigger arc minus the smaller arc. Here the order matters because we are subtracting. What happens if you would subtract a smaller number from a bigger number?
You get a negative.
You would get a negative. Do we have negative angles here?
No.
No. So you got to do the bigger minus the smaller. If you want to take one of your highlighters, we can highlight where the bigger arc is. It is still the intercepted arc, the arc between the two rays of the angle. And then your smaller arc with your second color. So your outside angle equals 1/2 times the bigger minus the smaller. Where's the outside angle in the first example? The one I have circled. Where's the outer angle? What's it called? Angle 1 is the outer angle. In the second one, what's the outer angle? Outside angle. Angle 2. And in the third, where's the outside angle? Angle 3. Those are where they are outside. So we're going to use this formula here because what kind of lines are intersecting this circle in our example?
Secant.
2 secants. So we're going to use this formula. The outside angle will equal 1/2 times the bigger arc minus the smaller arc. You don't have to write this formula every time or ever if you don't want to, but it is helpful at first. Bless you? Not a bless you?
No.
Okay, interesting. Okay, do we know the measure of the outside angle to plug in? We do. What is it? 30. 30 equals 1/2 times the bigger arc. Which of these is the bigger arc? A. Minus the smaller arc, which is 44. So again, I would not distribute. I would have 1/2 of A, which is not my favorite. So how do we get rid of 1/2? Multiply both sides by 2. Times 2. Times 2. Okay, so 2 times 30 is 60. On the right side, all we have left is A minus 44. And so the last thing we do is
Add 44.
add 44. And 60 plus 44 is 104. Again, you can always check. The angle 30 should be 1/2 of 104 minus 44. What is 104 minus 44? 60. And what's 1/2 of 60? 30. So you can always plug it back in to check. Okay, when you're ready, you can go ahead and turn the page. We're still talking about circumscribed angles. 2 angles, or an angle formed by 2 tangent lines. Which of these, 1, 2, or 3 of the original examples, which of these is a circumscribed angle that is formed by 2 tangent lines? 2 is. Okay, so the reason we could use this formula, in order to use it, you need to only have one thing missing. Okay, you can't have multiple things missing in an equation or you won't solve for anything. We all know this, right? So sometimes there is a situation like the next example. This is also a circumscribed angle, angle X, right? This is a tangent line, this is a tangent line. However, we only have, if we try to plug it into the formula from before, do we know the measure of the outside angle? No. Do we know the measure of the bigger arc? No. We would have too many things missing to use this property. So here's when you use this property. Go ahead and circle it. When you're given the central angle, or we'll say the...
Wait, highlight that whole thing?
No, what I circled. Or the arc formed by the outside angle. So most of the time you'd be given the central angle, but sometimes you'll instead be given the arc formed by the outside angle. And I will show you an example of that. But here's all that happens. The circumscribed angle is going to be 180 degrees minus the central angle. So the outside angle and the central angle are supplementary to each other. So if I wanted to find the measure of this angle, and I know that these two are supplementary, what do I do to solve for x? Subtract from 180. Subtract the central angle from 180, and that means x equals 60. That's it. And again, I couldn't use this formula because there was not enough information. I had to use this one. Okay, I want you to take out the cheat sheet for a second and explain why it says, or arc formed by outside angle. Okay, so go ahead and look at the cheat sheet. The third line, I believe. Yeah, this one. The third line. So we have an outside angle, right? But we cannot use the formula that we had before, where the outside angle equals 1/2 times the big arc minus the small arc. Do you know the bigger arc?
Yes.
No, you do not. And you also don't know the outside angle. So you can't use that. You would use this property because you are given the arc that is formed by the outside angle. See the outside angle? So this, in this case, we would use the property that I just showed you. Okay? Because this would actually be congruent to the central arc, wouldn't it? Because central arcs are congruent. Central angles are congruent to their arcs. So this one goes along with the property that I just showed you. So I would make a note of it. So what would the measure of the angle be?
Wait, we do 180 minus 138?
Correct.
Wait, hold on.
42.
So it'd be 42.
Wait, hold on. You said that angle, let's say angle M is congruent to...
Angle M? I haven't said anything about congruent.
I thought you said the one
The
that's like-
central angle is
Yeah.
congruent to its arc. That's not new information.
Okay, that makes sense.
So if you were given a blank circle, like with no lines on it, you've done this, right? Where I told you this was 60 degrees, that means the central angle is also 60 degrees. So
Okay, that makes sense, yeah.
this outer arc, the reason that I said this outer arc does not have any mathematical relationship with the outside angle. Only the angle, only the arc that is formed by the angle. So the arc that's closest to the angle, if you will. I know for certain this is not on the quiz. I do know it is on the worksheet, though. So if you're stressing about it, do not. It is on the worksheet, and you'll be able to use this paper on the worksheet also. Okay? At this point, you've learned all of the things, and we're just going to practice. So go back to the notes, and we go to the back page, and we practice. So from here, you've learned it all. You've highlighted it all. You need to now know how to apply whichever property applies to this picture. So in number 1, it says we have a tangent line. WX is tangent to the circle. We want to find arc YZ. Nope, I can't read. XYZ. I missed the X. So which of these pictures does it look most like? A tangent intersecting a chord, 2 chords inside of a circle, or an angle outside of a circle? A tangent intersecting a chord. So this 1/2 of the intercepted arc, that relationship is going to work. However, look at this arc that we want to find. Does it correspond with the 48 degrees we were given?
Yes. No.
It does not. 48 degrees corresponds with this arc. So you can do one of two things, and either one work. And every single class has been different. Every person is different. It depends on what you're more comfortable with. If this angle is 48 degrees, what can I do to find out how many degrees the angle next door is?
Subtract 180.
Subtract from 180. So 180 minus 48 is
132.
132. So if I know the angle is 132, what is the measure of its intercepted arc?
Double.
It is double it. So 132 times 2 is?
264.
Correct. So the measure of arc XYZ is 264. Nope, that's not what I wanted to write. Sorry. 264. Here was option 2, and some people prefer it. If I know this angle is 48 degrees, what is the measure of its arc?
Double.
It'd be double, which is 96. So then from here, what do you know about the circle, the arcs in a circle? They add 360. So if you took 360 and minus 96, you'd get 264. So either way. Number 2, let's look at this picture. Do we have a tangent intersecting a chord, 2 chords intersecting inside a circle, or angles outside of the circle?
Angles inside the circle.
Yeah, 2 chords intersecting inside a circle. So we're going to use this property. When you use this property, it is very crucial that you locate what angles are between the 2 arcs. Does X correspond with these 2 arcs? Does X form either of these arcs? It is not. So when we use this property, we're going to find the measure of these 2 angles, but that doesn't tell me what X is. What would I do afterwards? If I know this angle, how would I find the value of X? Subtract from 180. They'd be a linear pair. So again, X corresponds with these 2, and we know nothing about them. So in order to find X, we need to find this angle, which corresponds with these 2 arcs. All right, so we're going to use the formula. The angle equals 1/2 times the arcs added together, however you want to say it. This is how it is written on my cheat sheet. We don't know the angle. I'm just going to keep calling it an angle. Why wouldn't I want to call it X? There's already an X, and it doesn't represent what we're finding. So I'm going to find this blank angle. You could put a question mark. You could put a different letter if you wanted. I'm just going to keep writing angle. It equals 1/2. And then what are the 2 arcs we're going to add together? 114 and 122. What is 114 plus 122?
236.
Good. And what's 1/2 of 236? Correct. 118. So we just found these 2 angles are 118. But we want to find X. So again, they are a linear pair. They're right next door to each other. They form a straight angle together. So what can I do to find the value of X?
118 plus 118 minus 360 divided by 2.
That is the longest way to do it, yes. What is the shortest way to do it?
180 minus 118.
You're not wrong. It's just longer. So the reason I say he's not wrong, these are going to be the same measure, and they will add up 360, so you're not wrong. Just a little bit longer. But either way, what's 180 minus 118?
162.
Just-
162.
Just 62.
Yep.
Yes. Degrees, or, yeah.
Wait,
Yes,
I we got 118.
how did we get 118?
Yeah.
1/2 times the 2 arcs added together.
Wait, did the 1/2? That makes sense. 1/2 of 236.
Are we okay? Okay. All right, find the value of X. So which of these does number 3 look like? The angles outside of the circle. What kind of line is DE? Tangent. And what kind of line is GE? Secant. Okay, so it's going to fall under this. The measure of the outer angle, so the outside angle, is equal to 1/2 times the bigger arc minus the smaller arc. All right, so what is the value or the measure of the outer angle? 29. Equals 1/2. And then what's the bigger arc? 114. And then the smaller arc is X. All right, so what can we do to solve for X? What should we do first? Yeah, multiply both sides by 2. Multiply times 2 times 2. So on the left, 2 times 29 is 58. On the right, the 1/2 and the times 2, they cancel each other out. So we have 114 minus x. What is my next step? Subtract 114. So, this is where small mistakes happen and you don't want to make them. What is 58 minus 114? So it's negative, and it should be negative. What do I drop down on the right side? The negative x. So a lot of times, students make the mistake of forgetting that negative. But if negative 56 equals negative x, then what does x equal? Positive 56. Good.
Wait. How?
You can either divide by negative 2 or multiply both sides by negative 2. Either way. Alright, and then this last one I would put a star next to because I'm going to tell you a common mistake that people make. We're still going to use the same formula because what kind of lines form this outside angle? 2 secants. So we're using the same formula. The outer angle equals 1/2 times the bigger arc minus the smaller arc. But you got to be careful when you plug this one in. And I will show you why. What is the outer angle? 34. So the outer angle is 34. And then the bigger arc.
3x minus
3x
2.
minus
Correct. 3x minus 2. And then the smaller arc.
X plus 6.
Before you plug it in, I want you to pause and look. I want to subtract all of the smaller arc, correct? If I plug it in like this, what is being subtracted?
X.
Just the x. So what do I need to write in order to know that I'm subtracting both the x and the plus 6? I need parentheses. So I would probably highlight here because this is where, if you get this problem wrong, this is where you probably made the mistake. So those parentheses, because what we do next is because of the parentheses. I'm just going to combine first. Well, actually, no, I'm not. What would happen if there was just a regular number in front of parentheses? What do we call that?
Multiplication.
We do call it distributing. So what number is actually in front of this set of parentheses? A negative 1. So we're going to distribute just like normal. Negative times x, negative 1 times x is negative x, and then negative 1 times positive 6 is negative 6. Thomas, did you say what? You just did a chapter like this. Okay. All right, so now we add. 3x minus x is 2x. And then minus 6 minus 2 is negative 8. So if you want to distribute this 1/2, it would work here. It would work a lot better because both of these are even, so it'd be easy to do. But if you don't want to do that and you just want to be in the habit of multiplying both sides by 2, it's fine either way. So which one would we rather do?
The hardest way.
The multiply both sides by 2? Okay. Both sides by 2. It's okay. I already did it. It's fine. Well, what's 2 times 34? 68. On the right side, the 1/2 times 2 cancel each other out. So we have 2x minus 8. What is my next step? Add 8.
Wait,
Six-
how did it cancel out because it's parentheses?
Yes.
Okay.
Because 1/2 of 2 is 1. So it just goes away. 68 plus 8 is 76 equals 2x, so x equals 38. You could have, I think it's the simpler way, 1/2 times 2x minus 8. I'll just show you what it would have looked like anyways. What's 1/2 of 2x? 1x. And then what's 1/2 of negative 8? negative 4, and then you would have added 4 on both sides, and you would have gotten same thing. It worked here. It could work here because both of these are even numbers, so it's a lot easier than odd numbers. You're going to take out your whiteboard marker before you leave. I need you to answer some questions correctly. Let's start with just these two. Answer these two correctly. What? Oh, it was supposed to be crossed out. I forgot to tell you.
Find the value of x. I think x is.
So, identify which picture it looks most like and use that property. It's not a central or inscribed angle, so you gotta use a formula. So you gotta decide which formula it is. Correct. It literally looks like there's something. No, because you math wrong. The third line was good, so whatever happened between the second and last line. That's good. Keep going. All you did was add these two, but you didn't use the formula. You added these two to make that, but
Wait,
you don't have that.
I had 32, didn't I?
Shouldn't be 30 anything. I think it's correct. 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 So, when we subtracted, it's because the only ones that go together are the ones that are in a straight line. So this one, this one, this one. So on this picture, it's kind of that one. Is X between them? It is, so you don't do any of that. It's just this. You found this one, but I don't need that one, I needed this one.
I got it now. It is? Yes, sir.
Okay, on the first one, a lot of you are doing too much. Reagan, I know what you're doing, and let me just give me a second. Is X the angle for either of these arcs?
No.
Are you certain that X is not an angle for either of these arcs? It sure is. It's between them. So all you do is the formula. This is 2 chords, right? Is 1/2 times 50 plus 92. A lot of you are subtracting from something, and you should not be. 142. You should get 71, and that is the final answer. This is 71 degrees. This angle is 109. But I don't want that one. I wanted the one between them. So it's just 71. On the second, I'm not telling you how to do it. You do something similar. Find out. You have these 2 arcs. You can find the angles. You're not leaving yet, unless Chelsea. You can find the angle between the 2 arcs. And then figure out what this specific angle equals. And solve for X. Oh, who did? Shoot. Haley also got it. 5x plus 14 in the angle that you found. That's good. Keep going.
Girl?
Yep.
Wait.
You're on step 1 there. Where'd you get an X from? You don't plug it in this one, huh? Is that terrible attitude to have? Find what you can't find. Find the angle between 97 and 35.
I'm confused.
Find the angle. Okay, that's what the angle right next to it equals, right? That's what 5x plus 14 equals, not find x. So you're supposed to think it's. If you use the formula, what angle are you going to find?
The angle pointing toward 90. Oh, actually, I don't know.
The angle towards, yeah,
Oh,
97, and you're going to find the angle towards AB. Find that first. Do not ask me, correct. Do not tell me, so that's good. So if you find this angle, think about the relationship between the angle that you found and the angle I want you to find. There is a relationship between these two. And then set them equal. That's good. We're having a meeting and Mary, she'll just take a minute. We're having a meeting. That's what we texted last week, Monday, Wednesday. Okay. And we should have a meeting every single day. Yep. So this formula only goes for, look, you see how they're opposites of each other? I already highlighted for you what you find in the formula.
I did this right.
So find out what the angle next door to it is. If this angle is the highlighted green angle, what relationship does it have with the angle next door to it?
Help me, bro. What?
So that's what 5x plus 14 equals, is that number.
This day.
So then find out what x equals. You'll have to write it down. You're good. You got it right. Okay, give me a second. Did you get 20? Good. Okay. What is 1/2 of 97 plus 35? No, what is the whole answer?
132.
No, the whole answer times 1/2. 66. If this angle is 66 degrees, what is the measure of the angle right next door?
Wow.
It is not 66. 114. So I know that 5x plus 14 equals 114. Find x. Go.
I knew that. Ain't that a...
So we get x equals? Correct. 20.